All right, today we are continuing our study of minor gas laws. Remember, minor gas laws relate two of the four gas law variables. So as you just saw with the pop bottle and the fish thermometer, today we have the relationship between pressure and temperature. And this is called Gay-Lussac's law. This guy was French, that's why his name's pronounced a little bit different than what it looks. Gay-Lussac's law is the relationship between pressure and temperature. So that means we are not changing volume or amount. And as you just saw with the pop bottle and the thermometer, we already know what this relationship says. If the temperature of the container increases, then the pressure increases, or vice versa. If pressure goes up, temperature goes up. And the opposite is also true. If the temperature goes down, then the pressure goes down. And vice versa. If the pressure goes down, then the temperature goes down. What we haven't talked about yet is why that occurs. But if you think about what causes pressure and what temperature is, it's not too hard to figure out. What does temperature measure? What does it tell you about the molecules? How fast they're moving. So if you make them move slower, okay, that's cooling them down, right? Now think about, what is pressure? Or what is pressure caused by? Collisions. So if you slow them down, what happens to the number of collisions? Less, which means less pressure. You can also look at this the opposite way. If you increase the temperature, you would increase the velocities or the speeds of the molecules. That would give you more collisions, which would be more pressure. And of course, you could say the opposite as well. Decreased temperature means decreased velocities, which means less collisions, which means less pressure. As we learned with Charles' law, things that have a direct relationship often have division in their equation. So Gay-Lussac's law looks almost exactly like Charles' law, except we've swapped out volume for pressure. We still have the before case and the after case, pressure and temperature before the change, pressure and temperature after the change. And just like we had for Charles' law, we have one little side note. What do your temperatures have to be in before you start?
Kelvin.
Kelvin. You have to change them to Kelvin before you put them into the equation. So that little side note that we had for Charles' law still applies. A couple of examples. Story problems sound almost exactly the same as they have all week. If a sample of gas at 1.25 atmospheres has a temperature of 20.5 degrees C, what will the pressure be when the temperature is raised to 31.6 degrees C? If you're not sure where to start, make yourself a list of what you have and what you're looking for. We know that the pressure starts at 1.25 atmospheres. We know that the temperature starts at 20.5 degrees C. Add 273 to convert that to Kelvin, and you get 293.5. It says that the temperature is being raised to 31.6. Add 273, get 304.6 Kelvin, and that's T2. And then we're looking for P2. We know it's going to come out in atmospheres because that's what our first pressure is in. Once you've got your list, you can plug your numbers into your equation. Remember, for a test or a quiz, this is the step that I need to see. This is the minimum amount of work. We need to see where your numbers are going. Pressure 1 divided by temperature 1, pressure 2 divided by temperature 2. And from here, it's just algebra. Cross multiply and divide. So you multiply 1.25 and 304.6. P2, 293.5. Simplify on the left. Divide both sides by 293.5. How many sig figs should we keep? 3. Go back to the numbers in the question. Remember, that's not exactly the perfectly correct way to do things, but that's what we're going to do to keep things a little bit simpler. Go back to the numbers in the question. We should keep 3. You should get 1.30 atmospheres. Okay, one more example. If a sample of gas has a pressure of 765 torr and a temperature of 26.7 degrees C, what will the new pressure be if the gas is cooled to 19.6 degrees C? Again, if you're not sure where to start, make yourself a list. What do you have and what are you looking for? It tells us that pressure 1 is 765 torr, that the temperature is 26.7 to start with, add 273, you get 299.7. It's being cooled to 19.6, add 273, T2 is 292.6, and then we're looking for P2. We know that the units for P2 will also be torrs because that's what we're putting in for P1. Once you have your list, plug your numbers into your equation. This is the step that I need to see. Where did your numbers go? Cross multiply and divide just like we did before. So 765 times 292.6 equals P2 times 299.7. Simplify on the left. Divide both sides by 299.7. How many sig figs should we keep? Should come up with 747 torr. Depending on where you round in your algebra, your numbers may be just slightly different from what I have. I usually try to carry decimals all the way through. I use the answer key on my calculator a lot. So I try to round as little as possible. If you stop and round every time you multiply or every time you divide, you're probably going to get answers that are just a little bit different. That may still be okay. I just need to see your work to see where you rounded. So if you're doing that, you might have to show a little bit more work than just that first step. Okay, we have a worksheet to do, and that'll be it for the week.